All right, pre-calc guys, this is the last piece of section 1.3. We're going to talk about end behavior. I'm sorry, it's a little locked up over there. But I wanted to talk about one thing that we didn't get a chance to talk about when I used the other video, when we were talking about continuity and limits. Now, we can see limits, how something is approaching something on a calculator by creating tables. And this has created a table here. I want you to look at this. But I'm also right next to it going to display how we use the calculator. Okay, so give me one brief moment while I bring the calculator up. And I'm going to show you exactly those keystrokes. Hopefully you'll be able to see it. If you can't see it, then I'm really sorry. View, enable skin, view, enable skin. If I move it over here and make it big, that should be it. Okay. So here's the calculator. I hope you can see it. I should put it on the other side because we want to talk about this function here. This is already displaying a function, so I'm going to go to y equals and I'm going to clear that out. We're going to put in 2 times the absolute value of x plus 3 as x approaches 2. We're going to talk about 2. And it says here, go ahead and find out what f of 2 is, right? And we did, and we realized it does exist. Well, I want to see what happens when we use a table instead of looking at a graph to see if it's continuous or to see if this works, right? Because that's the second test to see if this function is continuous. So I'm going to put in this function. So I'm going to hit the 2. That's the easy part, right? Now, I don't know how to put an absolute value. Well, here's how you do it. Math. Scroll over to number, and you see the number 1, it says abs, you hit abs, and now you have the absolute value symbol. And all you have to do is put the x in, all right? Then scroll over, and all you have to do is hit plus 3. Now, you could just graph it. You could. And we could say, hey, what's that graph look like? And there it is. That's an absolute value graph, and we could, zoom in on it and hit the 2 and hit enter, and we'll zoom in and we'll see the graph. But we'd have to scroll up because our window's all messed up. But I'm going to zoom out. But here, I'm going to set a table. And some of you haven't done this yet. If I hit second and window, that's table set, right? I'm going to put in my own values for the independent variable, because I want to get a bunch of values that are approaching 2. And I'm going to use the values that they have in their table on the page. So if you see, we have 1.9, 1.99, 1.999, and then I'm going to start with 6.9 or set 2.001 and go back up. Now I'm going to hit second and table or graph, and now I'm going to start putting in those numbers. 1.9, enter. 1.99, enter. And this is how you create a table. And as you approach 2, you get closer and closer and closer to 2. Look, the output looks like it's coming real close to 7. All right? And so I'm going to use 2.001, and I'm going to see that's just over 7. And again, I'm going to use 2.01, just like that says, and then 2.1. And we're going to see, as it approaches from both sides of that graph, and we saw that, it was that V. As it approaches from the right, it's coming down to 7. As it approaches from the left, it's coming up to 7, right? And so basically, it's just coming in towards 7 on our table. And so that's how you create a table and use a table to satisfy the second requirement to see if this limit actually does show that this function is continuous. Now, if you looked at the graph, you can see that the function was continuous, especially at that point in time. There's no gap and there's nothing there. But I wanted to show you that. And once that's over with, I wanted to do the second part of this video, which is showing end behavior. And an end behavior is actually really quite simple. And I'm going to scroll up here, and I'm going to talk to you about end behavior. Left end behavior is pretty simple. Left end behavior as x becomes more negative, right? And we show that the limit of the function as x is becoming more and more negative. As x is going to the left infinitely, what's happening to the graph? And so in this graph, you would say the limit of x as it approaches negative infinity is actually negative infinity, because as you see, as it goes left on the x-axis, it's going down, 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 down. All right? And if you looked at this same function and you were looking at it as it went toward positive infinity, you would say it was going toward infinity. All right? And it's really, really quite simple. As x approaches negative infinity, the function ends up negative infinity. And that's really all there is to it. You're able to look at the graph and see where this function is going to end, if there are arrows on the end. There are certain circumstances where you'll have an endpoint, right? But, then you would say as x approaches, say there was an endpoint here. You'd say as we're going to the right, so we're going positive, we say as x approaches 2, its upper limit here is 10, right? If that was a point there and this was a continuous line after that, right? Up into that point. But really that's it. You get to see where the end is, and if it goes infinitely, it goes infinitely. If not, not. A very simple idea. I think the harder of the two was just getting used to the keystrokes on the calculator when we were talking about continuity. I'm just going to take a scroll down to see if there's anything super crazy or super fantastic. And looking at these two graphs, we can take a guess. We say, okay, well, as for this function here, as x, limit as x approaches negative infinity, if it goes infinitely that way, it looks like, f of x is negative infinity. Well, look at that. I mean, this is also headed downward. So if we had a limit as x approaches infinity, this function would show that it's heading off in the negative direction as well. So it's also negative infinity. And if you want me to write it out here and make it look like the other one, oh God, my infinities are looking horrible today. Negative infinity, and there it is. Well, let's look over here. We basically have a horizontal asymptote here, and we should, right? It's never, ever, ever, ever going to get to 5 because we have some sort of x, right? And it's always always going to approach 5 from either side. So if we say the limit of this function of x as x approaches negative infinity, we're just getting to 5. We're almost at 5, right? And that's as it goes to the left. Well, look at it as it goes to the right. We'll do the same thing with the positive side. The limit of this function as x approaches positive infinity, well, it's going to be the same thing. It's also almost getting to 5. And you can take a look at it, you can put huge values in there. Let's say, 5 million or a million. So 5 times a million is 5 million, and you got a million down here minus 2. Well, that's negligible, isn't it? So it's almost a million. It's 2 away from a million. So it's really just 5, right? So minus, 2 millionths. Real close to 5. It's just getting infinitely closer to 5, but never gets there. Does that make sense? Good. That's it. Those are the ideas. That's end behavior. That's the third part of this 3-part section here. Continuity, limits, and end behavior. And that's about it. So I'll post this video along with the other video. You'll go with your homework. You'll have lots and lots of homework for this. And thanks for watching. Again, if you have any questions, you got to send them to me via Google Classroom.